Hello, everyone. We are going to get started with our first lesson of the next unit, Unit 5. So, as usual, keep in mind that you have access to this presentation and the guided notes that go with it if you're able to print it. If not, please feel free to also follow along. And then at points, I will tell you to pause the video so that you can maybe try out a problem or check your own understanding. So I encourage you to do that as well. So we're going to start off with this warm up. So 8 centimeters is the what of the circle. So in this spot, I'm looking for a term, right? Or a vocabulary word. What does the 8 centimeters represent? Oh, well, that's the radius, right? That's the distance from the center to any point on the circle. So maybe you'll recall, and we just want to refresh our memory with some of the stuff, but how do you find the area of a circle? Oh, pi r squared. Right? So pi times the radius, which we just said was 8, squared. So 64 pi centimeters squared. Right? And if you want to multiply and use that pi button, go for it. Not necessary to do though. What about their circumference? Right? So the circumference is like the perimeter of the circle. That's like if I started right here, or really anywhere, and I went the entire way around the circle. It's the distance traveled around. So the circumference is 2 pi r. Circumference is 2 pi r. Well, and then if you remember that 2 times r, well, what is 2 times r? Well, that's just the diameter, right? 2 of the radius lengths are just the diameter. So we could also say that this is 2d. 2 times, oh, sorry, that's not what we could say. I just had a moment. Pi times the diameter. Right? They're the same thing. They're just different ways of representing it. So whichever way we do it, we're going to get 16 pi. And since it's just a length, it's just centimeters. Right? So just a quick review to get us in the mindset of circles. Because what we are going to be looking at today is to identify and describe the relationships among angles, radii, and chords. And these are all in circles. So you know what a radius is. You know what an angle is. I don't know if you know what a chord is yet, but we're going to find out. So a lot of what we're doing in this lesson is going to be focused on building that vocabulary. So there's going to be a lot of terms that we're going to go through. And then as we continue this unit over the next few weeks, we're going to continue to, circle back. Oh, that's funny. To these terms and go deeper into them. So right now we're just doing the surface level of defining them, looking at what they are, and identifying them. So you guys have this on your notes, so I would encourage you to follow along. So I'm going to zoom in, I believe, if I can do this effectively. There we go. So what we're looking at here is a chord, right? So it has 2 endpoints. I'm going to call them A, B so that we can talk about this more. But a chord is a segment with endpoints on the circle, right? So on that circumference of the circle. So the notation for this is the same notation that you would have for a segment, right? So each of these are going to have notation when we're talking about them. So it would be AB, and this is going all the way back to the beginning of geometry probably. So there's segment AB. This is called a secant, right? So it's kind of like a chord, right? Like it contains a chord. If I just focused on just from here to here, that would be a chord. You know what? I'm gonna refer to this. I'll call this point C and this point D, so we can look at the difference with the notation. So this is a segment. A chord is a segment. A secant is a line that passes through 2 points on the circle. Okay, so a secant is a line. So this notation would be the notation that you might remember for a line. So we were looking at CD, and how do we indicate that it's a line? Oh, like that. Right, if you put the endpoints on it, we're actually talking about segment CD, and that would have a length. I'm going to back up for a second. An example right here, a diameter is a chord, right? That has endpoint. That's a segment that has endpoints on the circle. And this passes through 2 points. I want to emphasize that on the circle. A tangent, I'm going to say line. I don't like that I changed colors. Is a line that touches one point on the circle and never enters the circle. Right, so it's never going on the inside of the circle. It's always like this is the only point at which it touches the circle. We're going to be exploring these a little bit more over the next few days. So it touches one point and it never enters the circle. Right? Again, it's a line. I mean, it could be a segment, but that's usually because it's just a part. I mean, I guess it could be a ray. I'll write all of that after I do the notation. So I guess it just depends on what we're exactly looking at. So like for this one, if this is A and I would need another point, let's call this G, then I'm looking at AG. Right? So it can be a segment or a ray. Do you guys remember what a ray is? Right, so if it was a segment, I would be dealing with AG with the segment symbol. If I was just looking at the ray, it would be AG with that endpoint and an arrow. Right, you're not going to have GA. That wouldn't really make sense. It's typically a line is usually what we're looking for. All right, let's keep going. An intercepted arc. So this is always a little bit hard to define. So an arc is a portion of the circumference. Right, so the intercepted arc is the part that's like cut off by an angle, right, or by chords or by segments. So the portion of the circle, it's formed by two chords, radii, and they could be formed by anything, secants, right? So this part of it is the intercept. It's kind of darkened, but this is the intercepted arc, and that is intercepted in this case by these two radii, right? So it's like the part that's eating it. Right? If you were to shade the whole inside, it's what part of the arc is there. It's formed by two chords. So to talk about this arc, I want the endpoints of it. So let's say this is SG. It is arc SG. And we literally put like an arc above it. So a central angle. This is the central angle. This is the angle I'm referring to. That's it. Okay, so this is A, S, T. So it's an angle whose vertex is at the center of the circle. Right? So A is the center, so we would name it. If this was circle A, right? You name a circle by its center. Name circle by center. So the notation for this, it's going to be an angle, right? Angle SAT. Or we could have called this angle A. No, we couldn't have. Angle TAS. Right? The vertex, the center, has to be that middle point. I think I'm going to make a note in here that the measure of the central angle, and we're going to go into this more, but I kind of just want to talk about this now. Measure of central angle is equal to the arc it intercepts. So the arc this is intercepting is ST. So what we would know right here is that the measure of angle SAT is equal to the measure, that's what the M means, of arc ST. Look at all that good notation. Right, and this is something we're going to get into a little bit more next week, but just to give you a small preview of that. The next one we have is another angle, right? So this one is called an inscribed angle. So I don't know how familiar you guys are with this, but we actually did this a little bit when we were doing area. I think, was that 2 weeks ago? I'm all messed up with my weeks. So an inscribed angle, if a shape is inscribed in something else, that means all of its vertices are touching it, right? So when we were doing that box method to find area, and we had all the vertices touching the box, it was inscribed in the box. So this is called an inscribed angle. So it's an angle whose vertex is on the circle, right? And it's formed by, what are these called? Two chords. Is it always formed by two chords? We might expand on that a little bit when we get to it more. So I'm gonna put a star there, and I think that's a good way to think about it for now. But there's processes that work like this. It's okay. Notation. Well, it's an angle, right? So let's say this is G A B. Right, so this angle right here is our inscribed angle. So this one would be angle BGA or angle AGB. So what arc is this one intercepting? Oh, right here, right? That's the arc that if I were to shade the inside of the angle, that is the part that it intercepts. So how many degrees is a whole circle if you went all the way around? 360. I'm sure I heard you all answering. How many degrees do the three angles of a triangle add up to? 180. What is the relationship between 360 and 180? Oh, 180 is half of 360. Oh, the measure of the inscribed angle, this angle right here, is going to be half of the arc that it intercepts. So the measure And again, this is something we're going to get to more next week. I just want to plug it in right here. Measure of an inscribed angle is half the arc it intercepts. Okay, so what this means is that the measure of angle AGB equals 1/2 the measure of, oh, let's use that notation, arc BA. Neat. Right, and that's a bit of an extension on it. So let's take a look. Let's finish up with some of these arcs here. So we have a minor arc and we have a major arc. We've been talking about arcs. So if you can tell, like, what is true about these, right? So a minor arc is going to be less than 180 degrees, which is a semicircle. Right? Or I guess I could have said between 0 and 180 degrees, right? And that might not be super meaningful to us yet because we've never really dealt with an angle, especially in geometry, that is less than 0 degrees, but it is good to say that it's between 0 and 180 because in all reality, you can have an angle that's less than 0 and you will be looking at that next year. Okay, so then we are going to be, the notation for this is just the notation you've been working with, right? I just want, well, where does that arc start and finish? Right? Here it is. So it's arc BA. Right? Or arc AB. Well, how did we know that we weren't going all the way around it this way? Well, it's a minor arc, so it's less than 180. So if I'm naming it with 2 letters, it's indicating to me that it's the shortest distance around. So what about a major arc? A major arc is going to be the longer distance around, right? So this is going to be between 180 degrees and 360 degrees, right? Like this is the larger arc. So if you look at this, this is just the other part of the circumference, right? So the notation for this is going to have 3 letters. Like, how do I know that I'm going the longer distance around? Well, I have to say, well, I'm going to go from B to D to A. Or I'm going to go from A to D to B, right? Like you're following it around, right? So this is going to be named, and not more than 3 letters, but it's going to be named with 3 letters, right? Means longer distance. So that's, like if I threw another point in there and I called this E, it's still BDA. I'm not going to say BEDA. Like it is 3 letters. I could say BEA, right? I could say AEB, but I'm not going to start putting in that 4th letter. To add on to this a little bit, if you add the sum of major plus minor arc with same endpoints, what are you going to get? Well, we said it was the other part of the circumference, right? So if I go BDA and I go AB, how many degrees is that? 360 degrees. Awesome. All right, so we just went through lots and lots of vocab that we're going to be using over the next few slides and the next few weeks. So let's just check our understanding with this nice picture. So I have like a word bank at the bottom, and we want to use the words below to label the circle correctly. So let's see what we have. We have arc, we have chord, we have circumference, diameter, radius, sector, which we actually don't know, but that's okay, segment, which we kind of know. But we know a different, okay, so these two are going to be a little different, right? So these two will be an extension. We know tangent. So let's start with the ones we do know. All right, so this right here, it looks like this part's highlighted. What is that? Oh, that's an arc, isn't it? Let's cross it off. Let's find the chord. Oh, I think this is the chord. Right, that's referring to this part right here. Oh, this is off. The circumference is the entire way around. What about the diameter? Oh, this is pointing to the diameter. Oh, I spelled that wrong. The radius, right here, we're looking at the radius, right? So the radius is just going to be this portion. So we did this. Tangent. This is the tangent, right? Remember, the tangent only touches the graph, the circle at one point. So that is the tangent. Okay, so then sector and segment we don't know. A sector is like, I'm going to add these in because these are going to come up later in our unit, just not for a while. So a sector is like a piece of the circle. It's like a piece of pizza, a piece or like a slice. Okay, so this right here is referring to a sector. The segment is almost like a piece of like the crust. So the segment is actually this entire part. So if I were to shade it in, so all of this is technically the segment, which is weird. It's like the part that's cut off by a chord, the area that's cut off by a chord. Area cut off by a chord or secant, right? A secant is a line, right? And a sector, I'll shade that as well. I get a new color. Maybe a nice yellow. There we go. Is like a piece of pizza. There we go. Awesome. I know it's a lot of vocab. So let's keep practicing. So using circle A, remember they're named by their center, we're going to write down one example of each of the following, and we're going to use proper notation. I'm going to write down more than just one example, but you really only need to write down one. I think this would be a great time to maybe pause the video and try this, right? And then finish watching and see if you get it. So a tangent is the line that touches the circle at one point, but it never goes inside the circle. So BH, I'm going to call my tangent line, right? If I had said BJ or HJ or HB, that would have been fine as well. H is the point of tangency. I think I'm going to write that. Is the point of tangency. What if we wanted to name a radius? I think there's a few options for this. Okay, so here's some radii that we could write down. And remember, it's a segment. So AH could have been a radius, or HA. AF is a radius, or FA. And AD would be a radius. Any of those would be perfectly fine. What about a chord? Remember, a chord is a segment. So HF could be a chord. That diameter is actually a chord. What else? CD, as long as you're talking about just that distance from C to D. D to G. And note I can switch any of these letters. Those are the only three. A central angle has its vertex on the center. So let's see, there's going to be a few of these. I could do HAD. Oh, that is not right. That was supposed to be an A. Angle had HAD. DAF. Right, and again, I could have said FAD, or I could have said DAH. I believe those are the only two I can really do, because it's formed by two radii. What about an inscribed angle? So this is where the vertex is on the circle, like on the circumference of the circle. So CDG. I think that's the only one, right? Even though CDA is on the circle, it really doesn't fit the definition because it's not formed by two chords, right? I don't really see any others. Sometimes people consider like BHF, but I'm not going to. And then a secant is a line that passes through the circle. So CD would have been a segment. I'm sorry, a secant, and make sure you put the line symbol. I think that's the only one. Yeah, that's the only one. So identifying. Let's keep going. Okay, how do we name this circle? With the center, circle A. With the center. So we're going to match the letter of the part of the circle with the appropriate vocabulary term. So I have A through E over here, and then A through E over here, and we're going to be using this picture. So what does AB represent if we look at this? AB, it's a radius. So let's see. Oh, it's a radius. Line L. Here's line L. What is that? Oh, that's outside and it only touches the circle at one point, that point of tangency. That is a tangent. So this is a tangent. What about line M? Oh, it hits it. Oh, it hits it twice. It's a line that goes through the circle. That is a secant. So C is a secant. Let's see, what else are we looking at? BC. So what is B all the way to C? That's the diameter. And then our last one, yes, we might know it just because it's our only thing left. But DE, it's a segment whose endpoints are on the circle. So E is a chord. Fabulous. Same idea, how do we name this? And for real, if you haven't paused the video and tried any, I really would love for you to. Name it with its center. This is going to be circle K. Ooh. Again, we have some multiple choice over here that we're going to be naming it with. So this is, oh, that's not a very good symbol. It got like stretched out, but that's the arc symbol. These are all the arc symbols. Remember what it means if there's 2 letters versus 3 letters? Just redrawing these. So GHF. So we're going to follow the circle in that way. So G to H, keep going. All the way around to F. That is a huge arc. That's a major arc. There we go. Hey, that's a major arc. What are GF? So from G to F. And what's the other one? G to H. Let's see, what do we have? They're not central angles. I mean, they are minor arcs, but it just says minor arc. They're definitely not a semicircle. Are they adjacent? Well, adjacent means next to. Yep, so they must be adjacent. We're going to put B there. What about GF and HJ? New color. So GF, so from here to here, and then from H to J. They're central angles. I mean, they're minor. I mean, no, they're not central angles, but they're intercepted by central angles. They're minor arcs. They're not semicircles. I guess they're minor arcs. I think I'm missing something. That's okay. So they're minor arcs. Let's go with that. C. I'm going to put B over here as well because I think B also falls there. This is also, so these are central angles. So this arc is actually also 63 degrees. And that's what I was trying to get at when I was talking about the vocab. This is also 63 degrees, right? So these are actually also congruent arcs, right? So I can also say that GF and HJ are congruent arcs, right? They're the same length and the same measure. Same length. So length is like a distance, measures like the angle. And measure. What about GKH? GKH, this right here is a central angle. What about FJ and FGJ? FJ and FGJ. Oh, those are semicircles. Those are 180 degrees. Those are half the circle. E. And what about GH? From here to here. That is definitely a minor arc. Lots of vocab. Make flashcards or use the Quizlet to practice these. It's a lot. Okay. Oops. Let's finish off with this last one. So we're going to actually find some measures. So I'm going to go take it a step further. So remember that a central angle is equal to the arc that intercepts. So what we know is, what does this symbol mean? 90 degrees. So that means that the arc it intercepts is 90 degrees. I'm just going to fill in what I know. This angle is 40, so that means the arc it intercepts is also 40 degrees. AD is the diameter. Or you know what, actually? Here, even better. What is the relationship between these two angles? Angle BFA and angle DFE are, oh, do you remember it? Vertical. They're vertical angles. And vertical angles are always congruent. They're formed by two intersecting lines or chords, right? So this is also 40 degrees, which means that this arc right here is 40 degrees. What about this one right here? figure this one out, right? So I know this part's 40. What is this portion going to be? This is going to be 180 minus 40, right? It's a line. They're supplementary angles. So this is going to be 140 degrees. And then last but not least, what about this arc? So I want to find its central angle, right? So we actually know everything. A whole circle is 360 degrees. I know this is 180. I know this is 90. I know this portion then has to be 90. So I'm going to just do, right? So I'm left from A to C, arc AC has to be 90. Let me re-explain that though. We know that arc AC has to be 90 because it's supplementary, right? These three right here are going to add to 180 degrees. We already took care of this 90, so what's left over is 90. That intercepts arc AC. So then if I do 90 minus 40, which is this measure, I'm left with 50. So this is 50, as is the angle it intercepts. And I'm going a little bit farther than you might need right now, and we'll be doing more with this next week. So arc AB, let's just fill this in, is 40 degrees. CD, we know, is 90. AD, what is the measure from A all the way over to D? 180. What about BC? Oh, 50. Isn't it nice when we already have it done? DE, 40. CE, how do you get C to E? 90 plus 40? 130. Oh, AED, so it's going to be over 180. AED. Oh, that is 180. What about ADB? ADB. It's everything but that distance, right? So those are, they add to 360, just like we were talking about. 360 minus 40 is 320 degrees. Fantastic. So in this lesson, we had an opportunity to learn a lot of new vocabulary, identify and describe relationships amongst angles, radii, and chords, right? So lots of new vocab. Which we are going to be using and looking at more closely over the next few weeks. Thanks for watching, guys.